How's it going, people? So we made one physics video, and my Earth Science students were immediately like, they want a video as well, and so here we are making a video, and we're going to make it on some topographic maps. So we have a topographic map problem from a New York State Regents, and so here's our map. Essentially, this is just saying questions 1 through 4 are on this map, and we have 4 points on it, A, B, C, and D. And so what we are going to do is answer some questions on this. Basically, these 4 questions are some of the most prevalent and the ones that are most expected for students to know. They pop up all the time on Earth Science Regents, and so let's get into it. So we have a map right here. We have a key right here on the map and a contour interval right here. And so question 1 says, on the map, draw a 200-meter contour line in the southern portion of the map and extend the contour line to the edges of the map. Now, let's do it. So I have a little, a working station. I'm sorry, my head goes away, which is okay. It's been a long day anyway. And so let's do a 200-meter contour line. And so what we have to do here for the 200-meter contour line is we have to identify at which points are above the contour line, which is like the 200, 250, 260, 230, which points are on it. So that's the 200s. So there's a 200 right here, there's a 200 right here, and there's a 200 right here, and which values are below, which are all these ones. And so the contour line is likely going to run through here, this area, but we have to get specific. So we always start at the edge of a map, and let's start with this one right here because this one's right on the edge. You could start with this one if you wanted, but let's go right here. So we connect this to our 200. Now the next thing we have to do is connect to another 200 value, and the next closest one is right here, but we have these other points in our way, and so we have to figure out where the 200 lies in between these. So we have a 180, a 210, and a 260. Well, 200 is clearly in between 180 and 210, and so the contour line has to run in between these 2 points, but definitely not touch either of them. So it'll run in between the 2 and 200. And so what we are essentially saying is that in between 180 and 200, we know there has to be a value of, 180 and 210, we know there has to be a value of 200 somewhere within this point. You can't go from 180 to 210 without hitting 200, and so it's somewhere in between. Now let's do the same thing over here. Well, we have a 180 and a 240. Well, 200 definitely lies in between those two. And then we have a 175, so we have to go above that 175. Right, every value that is below 200 is on the southern side of this. Every value that is above 200 is on the northern side of this. Now we have to go underneath 250, and let's hit our 200. Now let's go to the edge of the map. And so if we want to make sure, and this is a really solid way of figuring it out, if we want to make sure that we are correct, well, first off, we have to ask ourselves, 1, do we hit all the 200 points? And it looks like we have. 2, are all values that are greater than 200 on one side. So we have 250, we have 210, we have 260, we have 230, we have 240, 250. Yep, all the values that are above it are greater. And then our third thing is are all values that are below on the opposite side. So we have 180, 150, 160, 180, 175. It looks like nothing's out of place, and so we are good. Now I wouldn't recommend drawing on the map like this. I just wanted to point out where I was pointing, and so let's erase all these other ones. Let's touch it up a little bit because I erased part of that. So that's my contour line. Now this should be a nice smooth line. So that's the first question. As simple as that. And I'm back. So number 2 says, on the grid, construct a topographic profile along line AB by plotting the elevation of each contour line that crosses AB. The elevations of points A and B have been plotted on the grid. Connect all 10 points with a line from A to B to complete the profile. So we have a little profile here. Now let's do it on our workbook. And I disappear again. Now, what I'm going to start by doing is drawing a little rectangle. Oops, sorry. I'm going to start by drawing a little rectangle. And so it'll look something like the piece of paper that you normally get in class. And so you'll get a little piece of paper, and so what you are going to do is you're going to use this, in my case, fake piece of paper, and we are going to construct a little profile. And so what we do is we take this piece of paper and we put it along points A and B. looks a little something like that. That's good enough. And so I have put the piece of paper, obviously mine is transparent, so yours would be, you wouldn't be able to see this part right here. But what we're going to do is we're going to mark all the different elevation points between points A and B on our little piece of paper. So let's start with A. Now I'm going to shorthand this. Essentially, I know that all the values here are in the hundreds, so I'm just going to mark right here, point A. I'm just going to mark it 3. Now I know 3 stands for 300, and all the other 100 values can just be marked by single digit in that case. So I'm going to go through and I'm going to mark each one where it crosses. Alrighty. So we have a 3, a 4, and a 5 so far. Now we have to also notice that this is a 600 right here. This value right here, well, that's also a 600. We have a relative high point right here, so that these two values are also 600. Notice they hit the same contour line. It curves around. And now we start going back down. 5, 4, 3. Oop. Let me undo that one. It's a little off. 2. And then B is at 1. Great. Now we could take this point. Now this is the hard part. Figuring out this. Let's take this point. Now let's move it over here. Oh, look at that. Perfect. Slide it down a little bit. Now, when you do yours, you can actually slide your paper up and down. I'm just going to approximate it for right here. Just because I'm in the program and it's a little bit more of a tech hassle to do. So what I'm going to do is I'm going to just plot these points. Now notice A is already plotted. That's 300, perfect. Now we can plot 400 right above. Obviously you would be sliding your paper all the way up. So you can mark on the point directly. So there's a 3, there's a 4, there's a 5. Let's go to a 600. Right about there. Now we have another 600. Right here, a 500 that's pretty close to it, a 400 that's here, a 300 that's here, 200 that is here, and a 100 that's back down here. And so now we can connect these points, just like the question asked us to, and we should connect them once again in a smooth fashion. And notice that as we go up here, hit 600. Notice that this point right here has to be curved over, right? On our contour line right here, we do not see that A and B runs right along the contour line. So the A and B at this point right here is a little bit above 600. So we have to show that a little bit above 600. It comes back down and connects through all these points. Now notice we didn't touch the 700. Because, well, once again, we don't see a 700 contour line right there. If we saw a 700 contour line right there, then sure, we can hit 700. But because there is no contour line, it is just somewhere in between 600 and 700. So it'll look something like that. So that is question number 2. Alrighty, we're flying by. Now, let's go to question number 3. Let's get my head out of the way. Oh, we might not be able to get my head out of the way. We might have to zoom out a little bit. That's alright. Oh, maybe I'll just have to actually dodge. Or I could just read it out loud for you. Calculate the gradient between points C and D, and then label the answer with correct units. That's what it says right there. So, let's go back to my disappearing head that is getting in the way. And so, in order to figure out the contour line of points C and D, I am going to actually erase this profile. It gives us a little bit more room, so goodbye profile. You could always go back into the video and look at that again. Let's give ourselves some more room. There we go. So, in order to find the profile, or the gradient, let's first write down our gradient formula. So gradient is equal to our change in field value over distance. Now this is in our reference table. You definitely do not have to memorize this formula, but nonetheless, that is our formula. So we have to figure out, well, what's our change in field value? Change in field value is whatever we are representing in this map. And so this map is representing elevation, and we measure elevation in this map in meters. And so our point C is 600 meters, and our point D, if we go all the way around, is 300 meters. So our gradient, our numerator, is going to be our 600 meters at point C minus our 300 meters at point D. So that's our first bit. And now we have to figure out the distance, which is a little bit harder. Not too hard. So we're going to bring back our computer piece of paper. And what we are going to do is we are going to mark on the graph where points C and D are. So let's like this little, let's go to here, and we'll rotate it. Right, too much. Right there. That sounds good. So we have point C right here, point D right here. And so you'll be doing this on your actual piece of paper on the test. And we can move this. I don't think I selected that all that well, but let's see if we could still move it anyway. Let's see if we can move this. Yeah, that's good enough for right now. All the way around. That's fine, we could flip it. So we could see that these 2 points are just about at 4 meters apart from each other. Or sorry, not 4 meters, 4 kilometers apart from each other. So using our scale and our piece of paper, we can now say that these two are 4 kilometers apart from each other. Now mind you, I left my piece of paper over here, and that's fine. You will actually do it with an actual physical piece of paper that you can slide over a lot easier than I can slide over here. So we used this piece of paper to mark C and D, and then we moved it over to our scale to figure out that C and D are actually just about 4 kilometers apart from each other. So let me erase this just to make it a little bit cleaner. And let's put that in our equation. So that's my distance between the points, and that is 4 kilometers. Alrighty, so gradient now comes out to, I'm just going to simplify it. Comes out to, well, 300 meters divided by 4 kilometers. 300, or 600 minus 300 is 300. And so the gradient, I already calculated out beforehand, is 75. And we need a unit here. So the units here are meters per kilometer. Right, meters per kilometer in that case. Right, pulled right from the equation. And that is question 3. There you go. And we're almost done. Question 4 says, which you probably can't read the whole thing. That's all right. Identify the compass direction in which towards which Kim Brook flows. Describe an evidence on the map that indicates the water is flowing in this direction. So, we have Kim Brook right here. And so what we're looking at is these contour lines. Now this is, there are essentially 2 ways that you can go about this. One, you could say that water always flows downhill. And this point is certainly higher elevation than this point, and so it'll definitely flow downhill. Downhill to from a higher to a lower elevation. So that's one way you can do this. There's a little bit better, in my opinion, way of figuring out this, and that is remembering about these contour lines. So notice that the contour lines, when they hit the brook, seem to V. Now the V always points upstream. Always points upstream. So if this is upstream, then once again, that means that the river is flowing this way. And so the cardinal direction that it is flowing in, we would call that northeast. Northeast. So we can say either 1, the river is flowing from a higher elevation to a lower elevation, or 2, the contour lines point upstream, therefore it is flowing northeast. So those are all the questions that we are usually asked for the Earth Science Regents. There are some other topographic map questions that we can have, but those are certainly the most prevalent ones. So there you go, Earth Science kids, you got your video.